Hello, my name is Laurent Malané and I am a PhD student at the ICube laboratory in Strasbourg in France. Our work is about how to design the driving circuit of a square wave excited ring core for Fluxgate sensor. The Fluxgate is a magnetometer that is typically used when you want to reach a resolution ranging from 10 picoteslas to 10 nanoteslas, and for measuring static to low frequency field up to few kilohertz. The Fluxgate is made of a ferromagnetic core around which is woven a driving coil. This driving coil is in series with a resistor and a capacitor, which creates our whole driving circuit. The aim of this paper is to create a method to size each individual parameter of this driving circuit. For instance, for example, the capacitance, resistance, number of windings of the driving coil, etc. In order to do that, we did a behavioral analysis of the driving current being divided in 4 steps that depends on if the magnetic core is saturated or not. And from this analysis, we created a step-by-step method to size each individual parameter of the driving circuit, where each step is either a guideline or an analytical equation that you just apply as it is. Then, in order to make sure that our method is predictive, we did some experimentations. In order to do that, we started from our own design specification and we used our own method to size our driving circuits. And this is the result we have obtained. In green, you can see the expected behavior with how we have set the parameters, and in red, you can see the measure of the driving current. The parameter we look at is I0, which is the amplitude of the driving current at the end of a half cycle, IP, which is the maximum amplitude of the driving current, and T1, which is at which time the spiking here is occurring. And as we can see, there's very little difference between what is expected and what we observe, the main difference being on the IP value. However, this should not affect the behavior of the Fluxgate too much. So we have a method to size the driving circuit of a Fluxgate magnetometer. Thank you for your attention. If you have any questions, I can answer them to you. Thank you.